This is separations part 4, part A. Um, we're going to be determining the degrees of freedom for an equilibrium stage, feed stage, reboiler, condenser, splitter, and a section of the equilibrium stages in series, and determine the degrees of freedom for a distillation column and the typical set of a column's specifications for design and for simulation. So to start with our feed stage, we can go ahead and just draw that out, where we'll have our feed and then we'll have our liquid this way and then our vapor going up. And then we also want to account for our heat exchange, which we'll define as Q. And let's label these streams as 1, 2, 3, 4, and 5. And then we also want to take an account for temperature and pressure. Make that Q. So let's go ahead and jump right into finding out our degrees of freedom. So our unknowns within our stream, we're going to classify as 5 times C plus 2, as we have our 5, our unknown value, and then 2 streams. We're going to take an account for our heat exchange, which is just 1, and then our temperature and pressure, which we'll do 2 times 2 because this is taking account for temperature and pressure, and then we have 2 outgoing streams. And then for our known, we're going to look at our material balance, which is just C, our energy balance, which is just 1, and then our dP equality expression, and then this is essentially just 2 times 2. And then we also have our equilibrium expression, which is just C. And now we can calculate our degrees of freedom. So what we're left with is 5C plus 10 plus 3, which this is taking into account for our temperature, pressure, and heat exchange, minus 2C plus 5. So our degrees of freedom for our feed stage is 3C plus 8. Yep. Now for the equilibrium stage, is basically the same thing, so we get rid of that feed. So again, we'll start with our unknowns. For our stream, we will be left with 4 times C plus 2, because we're not accounting for that feed stream. Heat exchange is 1, and then our temperature and pressure is 2. And then for our known, our material balance is C, our energy balance is 1, and then our equality will be the same as before, 2 times 2, and then our equilibrium is 1. So our degrees of freedom, we are left with 4c plus 11 minus 2c plus 5. And so we're left with 2c plus 6. Just to clarify, our equilibrium is going to be C. I forgot to, it's not 1, it's C. Otherwise it wouldn't make sense. How do we get 2C? And so with our reboiler, obviously we have our heat exchange and our outlet with our inlet, which is our liquid, reboils, and then exits as vapor. So basically, let's start with our unknowns. In our stream, since we have 3 total, it's going to be 3c plus 2. Our heat exchange will be 1 again. And then our TP is 2. Now for known, our material balance, lost the word for a second, is going to be C. Energy balance is 1. Our equilibrium is C. And then our TP quality is going to be 2 times 2. So for our DOF, we are left with 3c plus 9 minus 2c plus 5, which we're left with c plus 4. And then for our condenser, the reason I have it placed right next to it is because it is pretty much the exact same thing, since when calculating degrees of freedom, the direction of the liquid or vapor doesn't really affect the degrees of freedom. So it is the exact same thing with 3 total outlets, or 3 total streams, and we have our heat exchange. So I'm going to have our 3c plus 2 with our heat exchange being 1, our TP being 2, our material balance is also C plus, and our energy balance is 1, with our equilibrium being C, and then our temperature pressure equality is 2 times 2. So what we're left with is the exact same equation of C plus 4 for our condenser. So now for the splitter part of this, basically what we're going to have is 1 stream in and 2 stream out. And one thing to note is that there's only liquid, so we will not be having vapor, which does affect this. So let's start with the unknowns. For our stream, we're going to have 3c plus 2. Our heat exchange, of course, is 1, and then our temperature pressure is 2. For our knowns, our material balance is C, energy balance is 1, but now we're going to have a little bit of a difference within our equilibrium. So now, since we have only liquid circulating and there's no vapor, there won't be an equilibrium to be met, so this is going to be just 0. And we're also going to account for our composition, which is C minus 1. And then our equality, which is just our temperature pressure, which is 2 times 2. So for our DOF, we get 3C plus 9 minus 2C plus 4. What we're left with is C plus 5. And now back to our equilibrium stage. We just want to add on a n factor to this. So basically what we're going to do is 2 times our DOF, which is 2C plus 6 minus 2 times n minus 1 times C plus 2 plus 1. And then after we combine terms, basically what we're going to be left with is canceling out the 2n C. I believe we're left with 2n plus, I believe, 2C plus 6. I'll have to double check on that, but I think that's what we are left with. Okay, so now what we're going to do is we're going to have to combine all of them. So for our splitter, what we got was C plus 5. This was C plus 4. Reboiler was C plus 4. Our feed stream was, I believe, 3C plus 8. And then for our reactor and stripper, we're going to have our 2n plus 2c plus 5. It was actually a 5, not a 6. And then 2ns plus 2c plus 5. And what we're left with is 2nr plus 2ns plus, I believe, 10c plus 31. And this is our degrees of freedom for our stages in series. So now what we're going to look at is our distillation column and calculate the degrees of freedom for our distillation column process. So I've already got our process written. So what we're going to do is we're going to have our 1, 2, 3, 4, 5, 6, 7, and then there's 8. And our equation for this is going to look like -9 times C plus 2. And then we're going to find the difference between. So subtract by -9C and then 18. We're then left with 2nr plus 2ns plus 1c plus 13. And this right here is our degrees of freedom for the distillation column. And now we're going to go through specifications to kind of cancel out how many degrees of freedoms we need. So if we look at Q and P, we're left with negative 2 nr minus 2 ns, which if we take out from this equation, we are left with c plus 13. We're also considering this at each stage. If we look at the feed in terms of CTP, we're left with negative c plus 2, which if we take out from our degrees of freedom, we're left with 11. If we consider an adiabatic splitter, we get negative 1, which is 10. And then if we look at our Q and P in our feed, we get negative 2, which gives us 8. And lastly, if we consider the pressure of the condenser, the reboiler, and the splitter, we get negative 3. So finally, our DOF will be 5. So that's our how many degrees of freedom for this entire problem. We brought it down to 5. And that concludes part A of separations homework 4.